Hello everyone, my name is 𝐒𝐤𝐢𝐥𝐬 and I welcome you to the finale of 5 days of 5 LLD challenge. In the last 4 days we have talked about so many topics. We started with solid design principle. Then we went to the design patterns and talked about the creational design pattern, we talked about the structural design pattern, and then finally we talked about the behavioral design pattern. So by now I believe we all have a solid foundation to start solving the problems of the interview, to start solving the real world problems which you get in the industries. So today we are going to take a very interesting problem. I'm going to design a vehicle parking system, a car parking system. And with all the concepts that we have learned so far, we'll try to apply those and see that when in the real world, when you work for the companies or in the interview, somebody throws you a problem statement, a new project, how do you decide what all objects should be created? What should be the attributes of those objects? How the objects interact with each other? All these thoughts we are going to develop in this single video. So today we are going to design a parking lot system, a vehicle parking system, and let's get started. So now let's directly jump to the problem. So the problem statement that we see on the screen right now is design a parking lot. What is a parking lot? Parking lot is basically a parking place where you go and park your vehicle. We all have been to the shopping malls, markets, airports. All these places you will have an area where you go and park your vehicles. Now, so whenever in an interview, right, if it is a system design interview, be it a high level design or a low level design, the interviewer always start with a very small statement like this. Design a parking lot, and will be pretty open-ended. You will not find any, complete discrete information around that. So now as a first step, whether you're working in an industry or if you're in an interview, your first step is to understand this problem statement well, right? So many of times here, for example, parking lot is a very simple example which we all are experienced of doing it. But let's say that someone tells you to design something, right, which you are not aware. Let's say that someone tells you to design a web crawler, and let's assume that you are not aware what that means. So don't feel shy from asking the details about this question. So the very first thing that you need to ask is that, what is that? We should always follow the strategy of what. So when you start solving a problem in the interview or let's say in a company, the very first important thing that you need to take care of is that what that problem statement is. Luckily, parking lot, we all know, is a place where you go and park your vehicles. Now once that is done, you will always have a limited time in the interview. You cannot solve everything. Designing a complete parking lot end to end, writing a code for it will take you a village of people and a month. You only have, say, like 30 to 40 minutes. So how do you make the best out of it? So next important thing to understand is that you have to understand the requirements, and you also have to understand what is the priority, right? Out of this, which one is the higher priority? So that logically in that limited time that you have of 30 to 40 minutes, we have to understand what are the things which are actually feasible, what are the things that I can actually design. So next logical question that you should ask Mr. Interviewer is that, sir, this is the time, I understand what a parking lot is, that what do you want me to build the features on, right? So let's talk about, so as a result of this, let's assume that these are the following requirements your interviewer asks you to do, right? What are those requirements? Let's try to understand this. So first requirement that you have, that you get is that, my number one requirement is that I'm able to park the vehicle. And then you can ask him what are the different types of the vehicle. So I can have the two types of vehicle for now. Let's say that I should be able to park car and I should be able to park bikes. Maybe in the future I would like to also allow the facilities of parking the auto bikes, or typically like the trucks and the more multiple wheel vehicles, right? So that's how I go and start with. The another requirement, let's say that interviewer tells me that at any given moment of time I should be aware that how many should be aware about, or I can say that no at any moment, right, numbers of available or blocked slots. Fair enough. That's number two, that at any given moment of time I should be able that in my parking lot, let's say that there are 100 places, out of which how many are blocked, how many of that are the filled with the vehicles, and how many of them are empty. That's number two. And the number three is that change the No, basically charge the vehicles based on the time they spend in the parking lot. The more a vehicle spends its time in the parking lot, you should charge them more. So maybe you will have some kind of hourly late rate or something. So let's say that these are the three basic high level problem statements that I have to go and solve. Now sir, when it comes about the low level design, the very first thing that you have to do is that for this requirement, typically what are going to be my classes? Because these classes will get converted into the objects. That's my first stuff. And then I'll have to also go and talk about what will be their attributes and the relationships. This is the main thing that, or the main objective of the low level design. I should be able to have a class level diagram. I should know what are classes, what are attributes, what are the objects, how they behave, how they interact. How do we do it? So trust me, this is one of the toughest thing to do. When you start building and you are as a fresher, you start building the application. This is the toughest time when you don't know where to start with. I'll tell you with the mantra which always works. So whenever you have any project, sir, whenever you have any project, the very first thing that you can do is that try to find that who are the actors in this project. If you want to further simplify that, what is the meaning of the actor, you can go and talk about who are the nouns. Identify all the nouns in your project that you can think of. So for example, in this vehicle management system, I can have the different nouns. For example, one of the noun could be the vehicle itself. Right? One of the noun could be the vehicle itself. The another noun could be, say, for example, parking area. Right? I'm just trying to give you a high level thought. I'm not saying this is the best design, final design or anything of sort. Designs are never best. It's always iterative. I'm just trying to help you that how we develop that thought, how do we start building applications. So we start thinking about the nouns, right? So one of the noun is vehicle, another noun is the parking area. The third noun itself could be the ticket, because ticket will be needed, so that there could be some timestamp based on which we can go and decide that for how much time the vehicle has been in parking. So we have something called as the ticket. Fair enough. Then we have something called as a parking slot itself, right? We have to keep track of the parking slot itself. So I go and type it as parking slot, right? Then we have something called as a gate, right? We have something called as a gate. We have something called as a user, right? The another could be, say, for example, the address. Fair enough. And let's say that another thing that I can think of right now is the payment system. So these are the different actors that I can think of right now in my brain when it comes about the parking system. So just like this system, any other application that you try to build, be it any application, what you need to do is that try to think about that who are the actors here, who are the nouns, and you have to go and define all these. So for example, in this case, I have vehicle, I have a parking area, I have ticket, I have the parking slot, I have the gate, I have the user, I have the address, and I have the payment system. Once we have finalized that, the next step is that you have to focus on each of these entities separately. You go and call this also as the entities, sir. Entities. Right? We have to go and focus each of these entities and also talk about what are my relevant attributes to it. Fair enough? So now let's try to go into each of these and try to finalize the attributes of all of these. So for this, let's go and cut this up so that I can use in the another page. Let me reduce this. Okay, and now let's start with the first one, which is my vehicle. Now if we go and talk about the vehicle, let's try to think about the vehicle. Now I know that there are multiple types of the vehicles right now, right? So for example, I have a vehicle of the type car, which I need to go and support. I have a bike. In the future, let's say that I want to go and support multiple different types of vehicles. For example, let's say that in the future, I also want to go and support the trucks. What that means that almost all these vehicles will have something common in them, right? And all those common things will be the part of the vehicle itself. So what we can do here when I'm designing it, we can have some kind of parent-child relationship. We can bring a concept called as an inheritance here. So what I can do is that I can have vehicles as a parent class, right? I can have the vehicle as a parent class, and then can have a child classes like the car and the bike. Fair enough. So now for each of these vehicle that I have, right? For each of the vehicle that I have, there are few common attributes that it should have. Right? What should be the attributes? So every vehicle should have a vehicle number, or I can go and say that registration number. Now in terms of the parking lot, now a vehicle could have many attributes, sir. It could have a color, it could have a manufacturer, it could have a brand. But when we are designing a system, we are not interested in all the attributes of a given entity. We are only interested in those attributes which is minimum and is needed for our functioning. Now in this car parking lot, this vehicle parking lot, I am only interested if I know a vehicle, the typical, the registration number, I believe that's more than enough, right? So this is the, the vehicle registration number, that's one. And what I need to also do is that, the car or a bike should also have some kind of a type, right? That what should be the type. So each of these car and the vehicle, right, which is inherited from the vehicle. So both of them will also have this registration number. This also have the registration number. And this indicates that this is of a car, so car will have a different dimension, the bike will have the different directions, right? So I think the car, bike or the all vehicles could be represented by just the registration number in this context. Right now we don't have to think about the relationship, right? So first of all, let's try to go and define all the entities, their behavior, and then we'll try to see that how all of them are related. Fair enough? So we are done with this. Now let's try to move with the next one. So here what I'm going to do is I'm going to take this up, copy this, let's try to move to the next one, right? I go and paste it here. Let's try to talk about the parking area. So if I go and talk about the parking area, sir, here, parking area, the parking area should have some attributes here, right? So it should have some kind of name. Every parking area has a name. And then the parking area should also have some kind of address. We see that already I have an address here, right? So we can also go and define this address entity. And this address entity will have something, say for example address ID, it could have a PIN code, it could have the street 1, I should have the street 2, right? Let's say that there's something called as a city, I have a country. So these are the information which helps me complete the address entity, right? So typically this parking lot and this address will have some kind of relationship, right? So here I can go and say that the parking lot also should have a address. Okay. Now when I'm talking about the parking lot, what all information the parking lot area should have, the name, should have the address. Fair enough. Let's wait here till this point, right? Let's move further, right? Let's try to move further. So let's try to now build another attribute. Let's come to the another attribute, which was my ticket. So when I come to the ticket here, sir, right? When I go and come to the ticket here, what are the attributes that the ticket should have? The ticket should ideally have the ticket ID, fair enough. And ticket should also have a timestamp, because we have a use case where we would like to charge vehicle based on the time how much they are staying, right? So ticket should also have the the timestamp, right? And the ticket should also have a type, right? Because you might charge a different rate to the bike, you might charge a different rate to a four-wheel vehicle like a car, right? So you should have that ticket type. And the ticket type could be, it could be an enum, right? The ticket type could be an enum, right? Which could have the value, say for example, it is like car or bike, like this, it would be an enum itself, right? The type of the ticket itself. Now, since I have built this ticket, right? Ticket is for what? Vehicle, right? So there has to be some kind of relationship between this ticket and the vehicle that we have created. Right, there has to be some kind of connection, because when the vehicle is parked inside the parking lot, there has to be some connection, right? The vehicle has to take the ticket. So what we should have is that, the vehicle should also have a field called as the parking ticket. It should have a field called as a parking ticket, because when the vehicle comes out, the vehicle should be able to provide that parking ticket, right? And for each of them, we should have typically a getter and setter methods, right? Because these will be the private fields, we have to follow the encapsulation, right? So we see a connection between the vehicle and this parking lot. We have already seen this connection. There is a vehicle and the parking lot, there is a connection, right? So ticket and parking lot is done. Now the next one is the parking slot. Let me take again, let me copy this and move to the next page for the clarity. So if you move to the next. Now we are left with this parking lot, parking slot. Now every slot should definitely have some kind of ID. Now every slot should have a type, which type of parking slot it is, right? It could be again enum, right? Where it could be a type for this car or it is for the bike, because the different parking slots should have the different types. Then it should also have a flag called is occupied. This could be of the type boolean, right, which indicates that if it is false, then it is free. If it is true, then it is already occupied, right? And this flag could be used to identify how many parking slots are there, right? So the parking slot has an ID, it has a type, and it is occupied or boolean. I think these are the attributes that I need to have. Now this parking slot, if I think around, can you guys tell me, pause the video and tell me which entity should this parking slot be related to? Parking slot should be inside what? The parking area, right? So if I go and find the relationship between the parking slot and the parking area, a parking area can have multiple parking slots. So there is a one-to-many relationship. So what I can go do back here is that in the parking area, I can put a list of, I can provide the list of parking slot, right? These are the slots that I have. Fair enough. And with this itself, these are the attributes. I should have a method to find, I can go and find the number of empty slots, and I can have the number of filled slots, right? So this is how the relationship of the parking area and the parking slot is defined. Cool. So I'm done with vehicle, parking area, ticket, address, parking slot. Now I'm left with these three: gate, user, and payment system. Let's try to see also them one after the another. So let me go and again copy this, and let's try to paste it here. Now if I go and talk about this, if I go and talk about the gate part, the gate. Now gate again will have something called as a gate ID or the gate number, right? And the gate could have a type, which again could be, say for example, an enum, which indicates that it is an entry gate or it is an exit gate. But now entry gate and the exit gate has two different functionalities. The entry gate does not have to do anything, just allows the vehicles to come in. But the exit gate has some additional responsibilities. What? The exit gate should have the additional responsibility of charging the vehicles, right? Taking the money based on the ticket, so that you charge based on how much time a vehicle has spent in the parking lot. So this way of defining the gate might not be right. So it's better that we go and make use of inheritance. So what we do is that this is not correct way of doing that. So what I can do is I can have a gate, and every gate will have an ID to indicate what ID it is, and the gate can have the two subtypes. I can have one called as an entry gate and have another called as an exit gate. We have an entry gate and we have an exit gate, right? And the exit gate should have a method to collect parking charge. Should have a method to collect the parking charge. And how it should do it? It should do with the help of, it should take two inputs. It should take one input as the ticket itself, and it should take another input as the payment system. Right? It should take the ticket and should use something called as a payment system. This is how the gate entity should look like on a high level. Fair enough. So we are done with the gate also. Now let's try to talk about the another entity, which is the user itself, right? So let me again go and copy this and paste it here. So we're going to talk about this user that you see on the screen here, right? I have this called as a user. The user, the different types of the users, right? So each user should have a name. Each user should have the address, which is of the type address that we have defined, right? It is let me go and put it more of like this. Right? And yeah, now this user could be the parent, and then could have a child user. So one of the user could be the customer. Right, the customer should have something called as a vehicle. Right, should have a vehicle. Right, and then we have someone called as an admin person. Right, admin can also have a vehicle, and admin should have a method called as she should be able to manage parking lot. He could have a method to manage the parking lot, and the admin should also have a field which indicates which parking lot that he belongs to. So he should also have a field called as a parking lot. Fair enough. So these are the users attributes that you have. I'm just trying to tell you that what should be the thought process, how you're going to find the entities in the very simple manner, just the getting started, right? Now, in the first iteration itself, you cannot look for the perfection. You might have the various scope of the improvement. So I'm just trying to tell you that how the thought process comes up, how do you start building stuff, and this is how you start thinking. Perfect. And then we are finally left with now the payment system. So I'll go back to my 8th, which is my payment system. So if I go and paste it here, right, I go and talk about this payment system. And what does the payment system do? The payment system should have a method called as take payment, which should take only what? It should take only something called as a ticket, and based on the ticket, it should be able to calculate the the rate at which it goes and calculates the tickets for you. So that's how do the payment system. So this is how, sir, we go and define each of these entities. What we do is that first of all, we take a problem statement, identify who are the actors, who are the nouns in the system, and then we go and define each of them. So for example, I have a vehicle, I have a parking area, I have a ticket, I have a parking slot, I have a gate, I have a user, I have address, I have a payment system. And for each of them, we go and define the class, we go and define the attributes, and we also go and define the relations. This is how you normally go and do it. And also a good practice is that how do we stitch all these pieces together, right? How do we go and stitch all these pieces together? So let's try to think with this help of example. So let's say that I have a parking management system, right? So if I have to go and manage this parking lot, I should have this parking management system. And what I need to do is, I need to start with something called as, the very first step that I need to do is that initiate the parking. Initiate the parking place. And for initiating the parking place, what I'll have to do there, I'll have to create the slot objects, create the slot objects. And once I've created the slot objects, using this, I'll have to go and create the parking place object that has to be initialized, right? And then we'll have to go and create the payment system object. Then you go and create the gates object, and when you go and do this, then the parking place gets created. So when I do this, I again get to see that few things I have missed. Say for example, when I go and create the payment system, when you go and create it, the payment system should be related to the gates here, right? So the gate should also have a, this is how you have a payment system that you have to go and pass in. And then every parking lot should also have the gates, right? So it should have a this parking, if I go and talk about this parking area, this should have something called as the other fields, like you should have the entry gate, and it should have something called as a exit gate, right? This is what we do. So when you go and try to stitch all together, many of times you will be uncovered few additional things that you would have missed, and that's how you go back and build those stuff. So if I come here, I go and initiate the parking slot like this, right? Then every time a user comes, then what I'll have to do is that I'll have to go and initialize the ticket objects. Initiate ticket object. Okay. Then every time every time a vehicle, so you'll have to go and create the user object, and then internally you will have to go and create the vehicle objects, right? And every time the vehicle object is parking, whenever the parking is done, right? Typically, if I go and rub this, whenever the parking is done, what we need to do is we have to go and update the flags. We have to go and update the flags of the parking place, right? So that you get to know that at any moment of time, how many are the free space, how many are the occupied space, right? And then whenever you do the exit, you take out the transaction, all that stuff. So this is the whole thought process of doing a low level design. Now purposefully in this video, I have not written the code because I wanted to keep this video as language agnostic. So depending on, once you have understood this, depending on the language of your choice, whether you want to write the code in Java or you want to write the code in C++ or Python, you would feel free to go and create the classes for this and define it. If you have understood this, take this another problem statement as an assignment. That problem statement is that what you have to do is that you have to go and define a vehicle renting system, just like a Zoom car, Now what you need to do is that you have to go and identify what are the actors in the system, basically what are the nouns, what are the entities, and then find out what are their attributes, how they are related, what their relationships are, and try to create this. And I'll be really happy if you are able to write the classes using the programming language of your choice, Python, C++ or Java. And if you are able to do this, you are able to do a low level design of this vehicle renting systems, please put that over the GitHub, tag me over the LinkedIn and let me know that you have been able to design the vehicle renting system, which is again a very common question asked in interview these days. I hope you guys really enjoyed this 5 days of 5 low level design series. If you have not watched all the sessions, please make sure you're doing it because it will help you in a great way in cracking the system design rounds of the modern interviews. Thank you and best of luck.